glad to be here. My name's Roland Barcia. How many people here identify as a developer? Freaking light, I can't see. All right. How many people identify as an architect? Not you. Platform engineers? DevOps? Platform engineer. DevOps teams back there. And okay. How many people here use Lambda? Everyone should raise their hand, right? Many people here are writing apps in containers as well, using both. ECS, Fargate. Kubernetes, EKS. Other Kubernetes. Any OpenShift. We have an OpenShift out there. Any Tanzu? I know there's one back there. Cool. All right. I'm really excited to be here. I heard some words in the keynote this morning that brought back memories like JMS. Before I joined AWS a couple years ago, I worked at a company called IBM. I was a fellow there. I helped build the original JMS driver for WebSphere application server to read messages off the mainframe queues and topics when it was called MQ series. The first application I wrote as a developer out of college before IBM, I worked at Chase Mellon Shareholder Services. The very first application was a Corba object in C++ that received an IOP call from Chase. And I took that data out of IOP with C++, wrote it to a queue, and sent the trade over to the mainframe at Goldman Sachs. So been doing EDA actually for quite a long time in my history. I think today we have great opportunity in the cloud. I want to talk about a quick example, and then I'm actually going to kick off a demo. And I want to kick off the demo and then explain the concepts after the demo. Because I want to be able, I'll show you, you'll see why in a minute. But I'm a worldwide director in our specialist organization. So I lead all the worldwide SAs for containers, serverless, and integration. So I have a bunch of SAs that are experts with Kubernetes, EKS. I have another set of SAs that are experts with Lambda, and others that ECS, Fargate. They all love each other, right? They all love each other. There's no internal competition, not at all. But worldwide, I get to travel. So last week I was in Seattle. I live in New York, or actually live in Jersey off exit 18E of the New Jersey Turnpike. How you doing? You know. But I got to travel. Before that, I was in Hong Kong, visited some customers, and this was a gaming customer. And I really loved this architecture. I abstracted out some of their specifics, but it was a gaming company that was using Stable Diffusion actually to generate images and icons for their gamers. And we went to the implementation. One of our SAs, Harold Sun, went with this architecture, and I'm like, this is an excellent example of using a bunch of our compute services together, right? So they had an application up there in ECS Fargate, so making some back-end API calls. API calls went to Lambda, and we're doing a fan-in, fan-out pattern of doing asynchronous prompt engineering. They're sending prompts to different model endpoints, and then comparing answers. Coincidentally, they were trying to really be controlling on the types of instances, because GPUs are at a premium sometimes, and there's different machine types, and they were able to get the performance they wanted on EKS. They kind of loaded the models for inference on EKS, and they were actually able to very quickly spin up G5 instances with Spot for savings. They want to use spare capacity. And they were sending these prompts there, and Keda was being used. If you were in the last session, D-Raj did a great job talking about Keda to scale pods. I'm going to go deeper there in a moment. But they were actually able to send these prompts to the model, and then send back the images at some point in time. The images are ready, and they let people who are able to choose and compare. This was an example of a use case. We're actually going to publish this on AWS Solutions, so it'll be out there soon as something that you can use as an example. But I love this because I see all the SAs in my team working together. I see all the, as the manager side of me is like, this is excellent, right? There's room for everyone here. And so what I want to do is go a little deeper on the two Ks up there, right? So Keda and Carpenter. So I want to start with the demo. And the reason I want to start with the demo is I want the capacity to ramp up, and then I'm going to start presenting, and that'll give it time to ramp back down to get back to current state. That's my hope. Okay. So what I want to do, and I'll explain a little bit here, is this is current state. I have an application, so I'm just narrowing in on a smaller part of the solution over here, right? So in the previous, I'm going to narrow in on how I can scale up pods and nodes. And you have to have a little bit of understanding on the way Kubernetes works. So pods are what, or you can have jobs, but pods is what runs my container. They get what's called scheduled. The control plane will schedule a pod on available nodes. Those nodes, in this case, are pre-provisioned. They can be dynamically allocated. And as I need more ramp-up time, I want to use Keda to scale up pods because a few more people came in. A few more people came in. They're like unexpected peak. D-Raj's insurance application went up high. Everyone's like, I want to do claims. I'm going to get in an accident on purpose to do claims because I love his application. So they all came in. They're all coming in, and the HPA, horizontal pod autoscaler, component in Kubernetes. Keda here is acting like a metric server, giving metrics and saying, hey, the queue depth has gone up. A lot of queues in there. I need more capacity. So I'm going to create some pods. However, realize those pods don't have anywhere to be scheduled. The nodes have filled up capacity. So what do? Carpenter comes in and says, hey, I want to be able to spin up some nodes. I want them to be beefy. I want them to be larger. And I want them to be spot so I can get the savings most of the time that you get with spot capacity. And just in case there's not spot instances, I want some backup as well. So this is the demo I'm going to show. I'm going to attempt it live on the conference Wi-Fi. I do have a video version. I ran it twice today, and it did not fail. So here we go. Let's go here. So this is what I have right now. Current state is I have a single pod running. There's different patterns for event-driven architectures. Some use a job that comes up, reads messages off a queue, and go away. I kind of, to make it a little bit more demoable, have a pod kind of looping and reading the message. Not best practice, but the code is there just to demo the scaling aspects. And I have two nodes. On those nodes, there's things that are running that are specific to Kubernetes, like the kubelet, the kube proxy, and then whatever tools I might have, but there's also the pods for the queue. So what I want to do is kick off, make sure I have the right window here. I had it at some point. Give me a second. So I'm going to go here. And somehow I lost the test window. So I'm going to launch a new terminal. Give me a second to do that. Actually, let me go here. Nope, I lost it. All right, so let me I'm going to go and do it quickly by creating a new terminal window. So, good. So CD. All right, cool. Give me 1 second. Pretty sure it's here. I know. Make sure I'm in the right folder. There we go. All right. All right, so what I need to do here is start. And this demo is, by the way, available. I'm going to show you where the code is. So I'm going to make sure I have the environment going. All right, go to my account. All right. So I'm going to copy and paste just some environment variables. Sorry, I lost the shell. Where's the paste? Copy and paste isn't working either. Nope. All right. So there we go. Cool. Next, I want to run the actual application. So here we go. Nope. What directory am I in? All right, so here we go. So we're sending messages to the queue. Let's get a couple more of these going. So what I want to do, all right. So I have 2 users going now. Oh, there we go. All right. And let's do that. So it's Python app. It's just sending messages. And let's go back to the scaler here. So what you see here is we're going to start seeing some pods start pending on the right. So these are the kind of workers. We got 3 up. I want to stress the system more. So let's do that. All right. So I want to simulate the 4 users. These are just setting some variables and then, oop. All right. Not bad recovery for losing all the state. All right? Okay, cool. So what's happening here is we see pods are starting to run, etc. We can actually go to another tool called EKS Node Viewer. See if that comes up and see what's happening as well. The tool we have for EKS, we have 9 and 12 pods. So let's see what happens. I'm going to ramp it up even some more. Let's do that. right. So I want to simulate the 4 users that I had before. All right, more. Oh. Go to my demo here. All right. So more messages, cool. So what's happening is, you see how quickly Keda is actually scaling up the pods. And so it's handling all the capacity over time. So we'll come in and say, hey, eventually you're going to start seeing a lot of pending pods. So we have right now no pending pods. So of course now it's performing like a champ. So let's stress the system some more, right? Let's add some more users. Let's do that. Let's get my right account here. Cool. So more messages being sent. Awesome. How are we doing? EKS viewer, 18 pending pods. That's what I want to see. Okay. So you see lots of different pods running. The 2 nodes are handling that capacity. And now we have a bunch of pending pods. I can't find anywhere to run. What's going on? So over here, EKS viewer will come around. Eventually, Carpenter is going to kick in and quickly load a node, hopefully. Let's see, Carpenter kick in, and then we'll kind of talk about that. There we go. So here's a new node being run. Let's look at EKS viewer. It's ready to go. And the pods are now being scheduled to run. You see it actually kicked off a second node, so as soon as it gets going, you have some brand new CPU nodes. You have different machine types, so you have an R7i extra large, a C5 extra large. You have on demand, so that's the initial capacity. Now I have spot instances running, and you're seeing 58 pods have been scheduled there, and it's handling the capacity. So if we go here to the AWS console, you see the initial nodes are from a managed node group that's also running the Carpenter agent, but you see Carpenter is spinning up these nodes. So we can let it run for a little bit more and then kind of get into the presentation. And I want to be able to scale it back down. So let's see how many more we can get. And you see, I'm using a tool here called K9's open source tool. You can find nice little open source tools in the ecosystem out there. More nodes coming up, more capacity, more workload, as lots of messages are coming in. That's what we want to see. As a platform engineer, they want to create a platform, let's say, to kind of enable this type of behavior, to get the instances I want, et cetera. So far so good. I'm going to shut down the requests. And we'll check back later to see if it's scaled back down. So the 5 users. Sorry for the hiccup in the beginning. I think we recovered okay. Let's get back to the presentation, and I'll show these things as we go through it. So that's current slide. All right. So this is what we had as a demo. Kind of came in. What you saw was the existing capacity kick in. Keda kicked in, scaled up a bunch of pods. There was just one. Now there's a bunch more. And then Carpenter kicked in and created a bunch of capacity to handle the spike and load. And it used a spot to provision it. So how did we make that happen? I'm going to talk a little bit about, I'm not going to go deep into all of Kubernetes, but when we're talking about Kubernetes, we have the control plane. With our Elastic Kubernetes service, we manage that control plane for you. A bunch of stuff runs on that control plane. Like the key things we want to kind of get into here is cluster autoscaler and HPA, horizontal pod autoscaler, VPA, vertical pod autoscaler as well. These are components that are important. And then you have the data plane, which runs your applications. We have different ways in EKS to run the data plane. We have managed node groups, which gives you some benefits around things like upgrading the nodes, upgrading the AMIs, provide some capability as well. A lot of customers are now using Carpenter. So Carpenter is an open source project we launched a few years ago. It's gotten a lot of traction around that. I'm going to go deeper into Carpenter to schedule the nodes. And then there's self-managed node groups, third-party schedulers, things like Volcano or Unicorn are examples of schedulers that you can use out there in the ecosystem. We have customers doing it all. Just so everyone has the same background, when we're talking about pods, we're using the horizontal pod autoscaler or vertical pod autoscalers, and they work on metric stores. It's reading metrics for the most part in Kubernetes by default. Get things like CPU and memory as metrics, and it tries to schedule pods around that, but you can plug in other metric stores, and that's the role Keda plays. Provides a metric store with a set of scalars that feed the horizontal pod autoscaler to create more pods and provide that environment. The way Kubernetes cluster autoscaler works is it detects pending pods. It tries to schedule those pods. If it can't find capacity, makes API calls by default to the autoscaler group in AWS. We talk about Carpenter, it uses something called, we call the Fleet API, but it scales up. This has been kind of a default pattern. It's the way Kubernetes works. So first, Keda. I think the previous session had a little bit about Keda. Keda is really meant to focus on the pods. So one, how do I get the pods up quickly? It's your application. Developers want some cool ways to do that. So Keda is meant to provide really a metric server that exposes a rich set of metrics and events from all different types of sources, and it informs the horizontal pod autoscaler to actually scale up and down those pods. And so, for example, we have autoscalers, it's open source project, out there for AWS sets of services. So SQS is the example we use, QDepth. There's other ones. For example, Kafka. Use our managed Kafka MSK service, for example. We have managed Kafka in AWS. We have managed Flink. We can use those services. ActiveMQ. We have Amazon MQ, which has Rabbit and Active. So you Rabbit down there as well. So you have all sorts of things. Dynamo database streams, Kafka for streaming. There's all sorts of very cool different scalers out there. So I have scalers that are connected to things like Prometheus, Grafana, Loki, which is part of the observability side of the house. So if you have an observability strategy, you're serving up metrics from something like Loki, it could do that. Serving up database calls, all sorts of different things, New Relic. So you have all different sets of scalers available to you, and Keda helps you do that. A little bit more on the Keda architecture. You have a scaled object. That's a configuration. I'll show you the scaled object defined in the previous section. I actually have a slide that is talking to the Kubernetes API server. It provides kind of the scalers, a controller, and the metrics adapter. It sends requests to HPA to say scale up, scale down by whatever measure. So that's what it's doing for you. So you can define a configuration, scaled object, give it a target, in this case an SQS queue. Started with 1, you can have 0 events, you can do jobs, so you can start scale to 0 and scale up. Maximum replica count, lots of pods I allowed. How often do you want to, each scaler has its own implementation. In this case, SQS is polling every 30 seconds to check the queue depth. And then different types of trigger sources, so what is the actual queue, what region, et cetera. Okay? You could actually put an idle count. If you want it to go down, sometimes depending on the scaler, it's ignored. So if there's no traffic going on at all, scale down to 0. You could also do scheduled scaling, lots of different cool patterns. So here's another example of a scaled object based on cron. So you could maybe have a Black Friday event. When I was in Hong Kong, I think it was called 11 Day, something like that. 11 Day was their scale-up event. Like 11 Day is coming, and we were close. That's the day that they get traffic for retail and things like that. You could actually run cron jobs and say, I know I'm going to have capacity hit in the morning. Want to scale up. You have another scaled object that scales down afterwards. So lots of cool patterns that you could do. This works at the pod level. However, if I have lots of nodes up and running and I'm paying for them, what's the point, right? Goal is I want to scale up, I want to scale down, get benefits that you get for free, like with Lambda, for example, right? Lambda scales to 0, pop up an event, function runs, goes away. I want to have that type of behavior as well. EKS, I have Lambda envy, right? So I want to get that in the Kubernetes world, because in this organization that I talked about earlier, they had different teams. This team loves serverless, serverless first, Lambda, Fargate, and this backend team. I love Carpenter. It gives me my GPUs when I need it. It schedules up the nodes. So we got EDA brings that all together, right? That was the message. EDA, everyone's decoupled, event-driven architecture. It's a point. But I want to make sure I get the benefits from the scaling side. As Carpenter is vendor neutral. The scalers actually are there. We're actually at KubeCon in 2 weeks. I'll be there in Chicago. Anyone going to KubeCon in 2 weeks? Nobody? Okay. We'll be there. We have a lot of cool things we're going to talk about. Carpenter is actually going to become part of the CNCF. We're working with the CNCF right now to do that. It's really exciting. Carpenter is what gives us kind of the node scale. Now, we designed Carpenter really with a specific task in mind, because Carpenter does a lot of things well, and there's other things that it might not do as well. And that's on purpose. So the way Carpenter works, and I probably have a picture, but I'll probably talk to it, is Carpenter is made for event-driven architecture. Its job is to find not necessarily the perfect node, but a really good matching node that I can launch as fast as possible. So that's what Carpenter is doing. Is pending pods. I don't have nodes. I'm going to find the best node I can launch and launch it as fast as possible. So that's what one thread is doing. And with this other thread, the second thread in the background, and it's looking for optimization opportunities, such as, you know what? This node has 70 pods, and this other node has 3. I'm going to take these 3 nodes, move them to these 3 pods, move them to this other node. I'm then going to shut down that node so it can bin pack for you. It can do things, a cluster autoscaler does this as well, but it can say, hey, this node you're running is 4x large. You're only at like 10% CPU. I'm going to launch 2x large, half the size. I'm going to move those pods over and shut this node down. So that's a second thread running in the background, looking to give you cost optimization based on rules that you define. And so, if you need to have lots of stuff up and running ahead of time, if you need to spin up a machine learning model, probably want to do that with a con, because sometimes those images do things like I need to slice GPUs, I need to load NVIDIA drivers, if you're doing a lot of things in the image startup, and you're relying on Carpenter to launch something fast, but you're kind of doing stuff, then people start saying, oh, Carpenter is not launching things as fast as possible. It's probably not true. It's probably stuff going on in the image, and you either need another type of way to cron jobs, load the things up ahead of time and keep them up, or you could do something else. But that's kind of the idea with Carpenter. And so in my demo, so here we have, and I can actually show it live, right? We have Carpenter is the key, right? We have operator in spot. You could actually say spot, comma, on demand. You could say reserved, get me all my reserved capacity first, then go after spot, then go after on demand. You can actually put precedence in order. You can actually define things like, I want an instance size that's not nano, micro, small, medium, large. So that means when I hit this criteria, I want to actually load an extra large or larger. So if we go, let's see, back to, still have some nodes up and running. You see that the nodes the initial nodes were large, but now I have like different types of nodes, like extra large, etc. Right? Looks like it's actually, let me see, if I refresh this, you see we have extra large. When I did it earlier this morning, there was a 2x large, so it actually gave me a really large node. So you see, I didn't specify machine type, so in this case I have a bunch of C5s and an R7i. Oh. Sorry. All right, there we go. My bad. So you see you have C5s, R7Ls, like different machine types. You could actually specify machine family. So you could say, hey, I want only instances of this type. And then you can use standard Kubernetes taints and tolerance, or you can kind of use node labeling and things like that for the pods to do that. If you look here at, can you see this pretty good? Let me see if I could actually show you the provisioner we use. Actually use the shell script to kind of load it, if not very GitOps-y focused, but actually this is the environment name. So if I go for first the Keda scaled object that we used in the demo, this is the SQS namespace. That's what I set up with the environments, the queue name, the region, the namespace, where to get my credentials, etc. So this was the Keda scheduled object, and then for Carpenter, just to show that, we have something called a provisioner. So same provisioner you just saw, where I asked it, I only wanted spot. You only saw spot instances. And I wanted the new ones to not be nano, micro, small, or extra large. Gave it some memory limits. And this is what's called a provisioner. So with Keda, you get a scaled object. With Carpenter, you get a provisioner. That's what you configure. So go back here. All right. So purchasing option, you can put precedence order. Carpenter has other features like giving you a way to handle spot interruption. So AWS says, I want the spot instance back. I'm going to send you an event. It has a way to actually help you kind of take that spot interruption and switch the instance over to an on-demand or another type of instance, for example. So it has some helpers with there. Some best practices to think about. So a lot of things you can do with Carpenter. How many organizations have a platform engineering team in your organization, like a central team that manages Kubernetes clusters? Kind of? You said you have kind of a few people. How big is the platform team? Very large? How many? Okay, yeah. So these platform engineering teams are trying to create standards. There's all different models. At reInvent, I actually have a session with a New York Times architect on platform engineering and how they built their central platform. By the way, those platform teams, even though there might be Kubernetes platforms, still provision Lambda and ECS through those platforms. So they still able to support that autonomous choice. But you could have lots of provisioners. You could have a single provisioner that has all these rules. Might not be as flexible. What we see happening is these platform teams have a model like cluster as a service, but sometimes they might have like a large cluster with namespaces, and they share, different teams are sharing that cluster. Say every team has its own logical namespace, security rules that doesn't let me get into the other namespace, but then customer says to me, I just actually ran into this in a customer in Israel 3 weeks before the event, so very fortunate I was not there. But for all those folks out there, missed them. And so we have each namespace with a provisioner. So I'm like, hey, I want my workload to run in its own nodes, and I don't want to share those nodes with other workloads. This is a way to do it with multiple provisioners. So this is a way to say, hey, I have a group of folks, they have multiple provisioners, this namespace can be the label for the provisioner, and each one gets its own set of nodes. So that's an example of why people do multiple provisioners. Weighted, you can kind of define an order by which provisioner runs. So, this provisioner takes precedence over a different provisioner. There's different patterns to deal with, but you have to architect kind of these provisioners. Okay. How am I doing on time, James? Good? So far, so good? Cool. So I didn't have to use the video, but Asif, who's one of the SAs on our team that kind of built this, you can actually set up this demo yourself. So you want to take a picture. So a couple more things I want to talk about. So one of the things that we at AWS is we're customer obsessed. We have a bunch of managed services that do awesome things, like EventBridge, step functions. Last year at reInvent, I did the EventBridge workshop. I was able to be one of the moderators. Great tools. We have managed services, managed databases. But we have customers that say, hey, I run Kubernetes, I run EKS, I run a set of these open source tools I want to use. We want to make sure that AWS is the best place to do it as well, EKS. We have a project my team runs called Data on EKS, which has a set of use cases around things like AI ML. Customers come and say, I want to run Kubeflow. I want to run Ray. I want to run these different machine learning languages. I want to run Spark, EMR. We have EMR and EKS. Some customers have their own operators and things that they've built. Data streaming. So we've actually built a set of blueprints that are based on Terraform, should provision best practices and clusters with some of these different use cases. Because the EDA conference talk about some of the patterns that we've launched with, we have actual blueprints that show MSK, so that's our managed Kafka service, running with side-by-side with EKS, and we have EMR and EKS, but we also have customers that want to run the Strimzi operator, want to run Kafka on Kubernetes, have a cluster strategy. So we have a blueprint to help you if you want to do that. Of course, you're managing more there, but we're also doing things with Flink on EKS. This is the other side of the different types of patterns that we're doing. And so some of these are going to launch very soon. Actually, we just kind of launched the Flink service already, but we have different capabilities as well. This is an example of a customer that is using EKS with MSK, so Managed Kafka and Amazon EKS, to actually build a solution around highly available renewable energy. It's a really cool use case. We have that on our website. You want to do that. And so some of the blueprints we have available for you is EMR and EKS with Spark Streaming. We have open source Kafka, open source Flink, Apache NiFi on EKS. So we have different streaming platforms. We have some use cases and blogs down there available for you to kind of look at that. So kind of some key takeaways. I have also, if you want to take a picture with Keda Karpenter and their open source projects. In order to get the efficiency that you want from event-driven architectures in Kubernetes, it's really Keda plus Carpenter, where Keda gives you the nodes, the pod level scaling based on metrics like queue depth or stream size, etc. You have Carpenter that gives you the dynamic scheduling, spins up nodes really fast, flexibility, cost optimization to use Spot, and also things like Graviton with an ARM architecture. And I think with that, we have time for questions.